Buenas, este es el video 9 del tutorial de ROS. Este video consiste en un sistema de loop en ciclo cerrado donde se usa un publisher y un subscriber para controlar el movimiento del Turtle Sim. Y en el video básicamente lo que estaré haciendo es reproducir exactamente todo lo que lo realiza paso a paso. Entonces va a ser un poco diferente de los videos anteriores. Me parece que de esta forma se puede reproducir en forma bastante fiel el comportamiento de todo, el comportamiento deseado. Y como la variante es incorporar un script más nada más, no es tan sofisticado de realizar. Es básicamente análogo a lo que se realizó anteriormente.
Subscriber. And now what do we want to do? Well, we want to control the turtle sim with a closed loop control. So we want to control actually the turtle in the turtle sim node. What we will need to have, we will need to have actually the pose of the turtle to know where the turtle is. And we will need to send commands to actually this topic, command velocity. So we will create a node somewhere here that's gonna subscribe to the pose and publish to the command velocity. And this node is going to monitor the pose, so receive current position, and send an appropriate command depending on what it has received from the position. Okay, so the loop will be like, we are going to go to our workspace source folder, my robot controller. We have already 3 Python files. Let's create another one, touch. Let's do turtle controller.py, and then, so let's actually put this here, chmod plus x. With turtle controller. Okay, now let's go back to our source folder and let's do code dot to start Visual Studio Code in the source folder of our workspace. So we don't need this anymore. Okay, and now let's edit the turtle controller.py. So first things first, let's initialize the node and the file. So that's what then I'm gonna launch directly. Okay, let's create a with directly. Actually, we We can also, so let's save and let's install it directly. So we add a comma here, and then turtle controller is equal to my robot controller dot turtle controller with a colon and main, and let's save it. Okay, now let's go back to the terminal. Let's go back to our ROS2 workspace and let's do colcon build. That's it. For the initial direct controller works tool. If no, all right. So we will need to created a publisher to the command velocity topic, and then with a timer that was running here every 0.5 seconds, we were publishing some velocity. So publish actually a new command. Actually already know what we need to do here, and the name is so import pause. And then let's create a pause subscriber is equal to self create subscription, and the type is going to be pause. Actually, let's go back to a new line here, and then the name is going to be, let's just use the same name. Exactly. Okay, turtle1 pause, and then we need a callback. So let's create def pause callback with self, because we're in a class, and then pause. So we could put msg, but I can also put pause, the same, with colon and then pause, so that we say that this is a pause data type, which is going to help for the auto-completion.
Transmitiendo desde el centro noticioso futbolero.
For now, let's just use pass. Okay, let's keep the function empty and let's put it there. So self pause callback, and then 10 for the queue size. All right, so self create subscription, message type, the topic name, the callback, and then queue size. And just like this here, so command vel publisher is equal to self dot create publisher. What message do we need? So let's actually go back to draw cycle, where we actually did the same thing. We need a twist message from geometry messages, and the name of the topic is turtle1 command velocity. So let's do that from geometry messages.msg import twist. I'm going to put twist here, but 10 as a queue size. Good. So we have created a publisher and a subscriber. Now, what do we need to do? We need to publish something new when we receive a pause. So here we will need to check actually what is the current pause of the turtle, and depending on the pause, we may send different comments. But just to try, just to try and to make sure that we are actually sending some comments when we receive a pause, let's just send a very basic and stupid comment to the turtle just to check that our code is working and that the callback is working, okay? Step by step. When we are sure that this is working, then we can think about what's the best way to control the robot, okay? So let's actually create a comment. So I'm gonna use comment is equal to twist. Okay, we receive a pause here, and we're gonna create a comment that is actually a twist, all right? And now in the twist, what do we have? So let's do comment dot. We have angular and we have linear. So for this first step, let's say that we just want to make the turtle go forward. Even if it hits the wall or the edge of the window, that's okay. We just want to make it go forward. So I'm gonna do command linear dot x is equal to, and let's use 5.0 as a velocity, and then command dot angular dot z is equal to 0.0. I'm gonna leave the other one to 0, so no y and z linear and no x and y angular, okay? I'm just gonna focus on the x linear and the z angular, like I explained before when we did the draw cycle node. So we have a twist command. Now I can do self dot comment vel publisher dot publish with the comment. Okay, so here we don't use the pause yet, but we just publish when we actually receive a pause, so in the subscriber callback. Okay, so this should be okay. Let's save the file and let's go back to the terminal. I'm gonna build an turtle sim node. Okay, we have the turtle right there, and in that one, let's run the controller. So ROS to run my robot controller, turtle controller. And now let's look very closely at what's gonna happen to the turtle here. I press enter, and okay, the turtle is moving forward and then hitting the wall, okay? And you can see I hit the wall, etc. So the thing is that it's working. It is doing exactly what we wanted to do, which is that when we receive a pause, so here with the pause callback, we send a comment to go forward. So that's exactly what the turtle is doing. And that's already a good progress in this application. So now what we want to do is we want, of course, to not make the turtle hit the wall, but to actually, let's say, to turn around when it gets closer to the wall and then come back and continue and just continue to move indefinitely. And so to do that, we will need to know what are the coordinates. And so I'm going to show you very quickly what are the coordinates. So let's just kill everything. Let's start the turtle sim again. And here I'm going to start the teleop. So ROS2 run turtle sim. Well, here let's do clear and let's do ROS2 topic list. We have the pose that we can subscribe to. And in the pose, you have the pose to just bring the X and the Y coordinates, which is basically what we want to know right now. So I'm going to use this instead. ROS2 run my robot controller with pose subscriber. Good. And you can see we have so the X here and the Y. And so at about the X the turtle, you can axis. So we are at 11 diagonal. Okay, so let's go to the bottom right. Let's focus here. Okay. And we should reach 0 and 0. Yes. Okay. So you can see, I'm gonna stop this one. You can see that in this window, we start at 0, 0 here. And then on the x-axis, we go until 11. On the y-axis, we go until 11. So we know what are the coordinates that the turtle can reach. And so what we could say now is that if the turtle is close to the border, let's say by 2, so if the turtle reaches, for example, x, which is 9 or more, then it should turn around. Then we can do the same with y is more than 9. We could do the same with x is lower than 2. And we could also do the same with y is lower than 2. So we can make sure that we actually kind of draw the square inside the square. This is going to be the safe square where the turtle can just move forward. And when the turtle goes outside of this, which is closer to the actual border of the window, then we make the turtle turn around. Okay, so again, let's do step by step. Let's actually start the turtle sim and let's imagine the current scenario. So the turtle is going forward. Okay, and let's just make it turn when it reaches this wall. And here we will need to use actually the pose. Okay, we will need to use the current position of the turtle. So what I could do here is to check that if pose dot x, okay, we have the x coordinate is greater than 9. So greater or equal, it doesn't really matter here. So if the x coordinate is greater than 9, what do? We do on the z axis. And so if the pose is greater than 9, we do this, but then we need to do also else, and I'm gonna put this in the else. So we only go forward if the pose, so if the x pose is not greater than 9. All right, so we have two different commands depending on the current pose. And then we, of course, publish the command. So let's save this and let's see what we have. Source /rc here. Let's run the turtle sim and let's run our controller. So not pose subscriber, but turtle controller. Okay, good. You can see it's turning and then it's going again, and of course it's gonna hit the wall because we haven't specified what to do if the x is lower than 2. So as you can see here, the turtle was going forward because the x is lower than 9. When x reaches 9, we change the command. So instead of going to 5 speed on the x-axis, we go to 1, and then we also add an angular velocity. So the turtle is going to turn until, well, actually until the x pose is lower than 9, and in that case we just continue to go forward. So now what we need to do is we need to handle the case for the left part, for the top part, and for the bottom part, and that's gonna be actually quite easy. Although we make the turtle rotate, go back here, the turtle sim node again, skill to go straight. Let's say this, go back here, let's kill this one, source bash rc, let's start the turtle sim node again, and the controller again, and let's see what's gonna happen. Okay, we turn here, and then go straight, and then we turn, and then go out of this, let's turn, and you can see it's turning again. So here it's hitting the wall a bit, but that's okay. Okay, and we turn again, etc. So for example here, I'm gonna stop the controller, and you can see when I stop the controller, well, the turtle just stops moving. So you can see here we hit the wall, and if you want to avoid that, you may want to actually increase the angular z velocity here. But if you do so, for example, I'm gonna do 1.5, okay, and let's see what's happening. I'm gonna angular. I'm gonna stop the controller, and you can see here. Controller I want to z 1.5, okay, and let's see what's happening. So let's start the turtle sim, and then I'm gonna source the bash rc and do the turtle controller. Okay. What may happen is that the turtle at some point, so let's wait a bit. Okay, you can see this behavior is that the turtle is actually gonna be stuck, because if it turns too fast, it may stay over the limit, and the limit here is y9, so the turtle is over the limit and is stuck. So that's why I have actually reduced the angular z to 0.9, because that's a value I found that works. You could go down even to, for example, 0.8 or 0.7, and that's okay. Even if the turtle hits the wall at some point, that's really not a problem. Okay, we are experimenting with ROS2 here. That's just a simulation. All right, so let's run it again, actually. So let's kill this and then do source bash rc, and then so let's, and as you can see, the turtle is continuously moving and turning when it reaches the edges. All right, so everything is working correctly. And let's just run RQT graph to finish here. And now we can remove dead things and leave topics, and you can see we have our closed loop control. So we have the turtle sim here and the turtle controller node, and you can see the turtle controller is listening to the pose and then sending data to the command velocity. So we have a closed loop control here. All right, that's the end of velocity. So we have a closed loop control here. Alright, that's the end of this episode.